Okay, back to the fan that we were working on last night. Got a couple of suggestions from YouTube members on how to remove this stator assembly, and I appreciate those very much. And I also read on one of the fan collectors' websites that it might not be a good idea to try to get this apart, and that it may be next to impossible to get it out. So I think what I'm going to attempt to do, since this head wire is so loose here, I'm going to try to separate this and run it back through here and insulate the whole stub of this wire with heat shrink tubing and then splice onto it. That's really not the way I wanted to do it, but if it'll save me some hassle and some possible destruction, then that's what we'll have to do. But at any rate, when I'm done with it, the wire will still be insulated and safe, so that's the main thing. Okay, let's see what we can do here. Okay, we've now got the old head wire separated and removed from the hole here. We ran it back through from this direction, and you can see where it attaches to the field coil windings on the motor, these little crimp-on blue wire nuts. So I think if I take my time and be careful, I can repair this without having to go to the effort of removing this stator assembly. Okay, we have the wires in here now and the connection soldered and heat shrinked. Now the fun's going to be very carefully routing all these wires through here and hoping that everything will fit in its proper place. Okay, success. We are all connected up and we have continuity. I originally was going to use the entire complete power cord that I'd saved off of something for the head wire, but I found it to be much easier to do this if I used two separate leads, so that's what we did. And like on the Robbins and Myers fan, I'll have to find some kind of sleeving to put over this. And I'm not going to lie, it was a little bit tedious fishing around down in there and getting everything connected, but we got it done. Okay, I've gotten it all put back together temporarily. I still need to take it apart and clean it and get all the junk out of it and lubricate it, but I just want to see if the motor will run. So, okay, it's either run or burn time. Let's see. Now, that's a pretty sound, isn't it? Thing runs like a top. Okay, so now all we got to do is clean this thing out and lubricate it and put it back together, and it should be mechanically ready to go at least. Okay, here it is with the blades temporarily installed. Thought we'd give this thing a pre-cleaning and lubrication test and compare it to post-cleaning and lubrication. Okay, here we go. This thing is moving an enormous amount of air. That Lakewood fan that I recently junked, I'd like to think it was a high velocity fan. This one would put that Lakewood fan to shame. Now, really all I have to do to this is clean the motor out and lubricate it and check the speed coil and replace and or insulate any wiring associated with that, because that wiring's in kind of bad shape too. So, we'll get to work on that right now. Here's our speed coil and off-on switch removed from the base of the fan. And this right here is somebody's idea of replacing the power cord. This is a white cord that they spliced onto the old cracked and brittle dry rotted cord that was on there. And here is our original head wire that went up to the motor. As you can see, it's just as cracked and brittle as everything else, as are all these interconnecting wires between the switch and the speed coil. So all these wires are going to have to either be replaced, or we're going to have to slide some heat shrink tubing over them to insulate them, because we can't have this. This is totally unacceptable. And one other thing we want to do is check the off-on switch, which you can do with a ohm meter. And as you can see, this switch has a reading, and you just check continuity on all three positions. And the nice thing about these switches, they can be cleaned and repaired if they decide to act up. These modern Chinese switches, when they break, that's it. And you'll also want to check the speed coil, and you do that just like you check the power switch. You connect one lead of your ohm meter to the speed coil lead that goes out to the motor, and then you simply take resistance measurements from these three leads that solder to the switch. Okay, there's one. There's two. And there's three. Okay, so this coil has continuity, so I'd say it's okay. Okay, here's a couple of wires that we have insulated. This is the lead coming out of the speed coil that goes up to the motor winding, and this is one of the leads going to the off-on switch to the speed coil. And the thing you want to remember when doing this is do one lead at a time. Unsolder one lead, insulate it, solder it back, do the next one. Even though this is a fairly straightforward circuit, a lot of fans have very complex motor wiring schemes, and the last thing you want to do is get your wires crossed. In this fan, like I said, this goes to the motor field coil. One side of the power cord goes to the other lead of the motor, and then the other side of the power cord goes right here to the switch, so it's not very difficult at all. And notice this lead right here going up into the speed coil, you notice the insulation has flaked off, and that could definitely create a shock hazard, so it needs to be fixed, and that's what we're going to do. Okay, our re-insulating procedure is complete. All wires have been re-insulated, and as far as I'm concerned, they're safe and good for another 65 years. Now all that's left to do as far as the electrical restoration is to replace the power cord and connect the motor head wire. And of course we still need to clean the motor and lubricate it, but we'll save that for part 3 since we're running low on time here. Okay, thanks for watching, and more to come later, and hopefully part 3 we'll be able to wrap this thing up.